Find the mass of a black hole when you are given the exact data of the position of a star that's orbiting the black hole, and you're assuming that the gravitational force of the black hole is the only force acting on the star. These are the equations you use for this, which we can see that I put that in my code to show the star's position around the black hole. Here, the first thing we put in was the mass, which was given, and the delta T, which was 86,400 seconds, which is equivalent to a day. And then, if we go down here, we can show, this is how we basically use the code to extract data from the CSV file that was given to us that had the star's position, and using it to show what the star's velocity in both the x and y direction would be. We're assuming that it's not moving in the z direction at all. Then if we go down here, this is where we start using those equations to show the motion of the star. We use initial velocity. This is again showing what we used up there to find the velocity given the position. This is momentum, which you get by multiplying the star's mass times initial velocity. The change in velocity and change in momentum, obviously final minus initial. And then dp dt, which is basically change in velocity over change in time, right there. And we know that F net is equal to change in velocity over change in momentum over change in time. We then find p hat by basically getting the initial momentum over the magnitude of the initial momentum, so it's the unit vector for the momentum. And we use this to find the magnitude of the change in momentum over change in time. And this is the parallel aspect of that. So we know that F net parallel is equal to change in momentum over change in time parallel. And same, we use this as for the perpendicular calculation because we don't have the radius in here. Otherwise, we could use momentum times velocity over radius, but we haven't defined the radius, so we use this instead. And then this gives us the net force in the perpendicular direction. We then came down here and I made this my arrow scale so that we could see each arrow. And down here, this is what we're printing. So we have the time, the magnitude of the net force, and then the magnitude of the net force in the parallel and perpendicular direction. So if we run this, this is the motion we get. Oh, it's going really slowly. Yeah, that's the gist of it. It takes a while, but I tried changing my rate. It, for some reason, has been acting a little weird. But so I decided to use this data point, which I've shown here. I chose this point because it's 2 steps. It's a time is 172,800 seconds, or step 2 basically, if you divide that by our time step. And then this was actually from the CSV file that showed, each position at each time step. So the highlighted one in this second column, or the second picture, shows the position. And I use this equation, given this is the position of the black hole minus the position of the star, which was given here. Each the x value and the y value added, squared and added, and the square root taken, and then that squared to do r squared. And gravity times the mass, and then the force is right here, the net force on the star, which I was put right here. So we're looking for m, which is right here. and I calculated that and got this for M, and Web of Science said that was correct. So that was good. And there actually is a difference in Fnet and dp/dt, because Fnet is an actual force, whereas change in momentum over change in time is basically how we observe the force, because change in momentum, we know the mass isn't really changing, so it's really a change in velocity. So it's basically how we're viewing the force on the object. So because we can't see a force, but we can see a change in velocity. So that's the difference, but they always have the same values. If the black hole was replaced by a different black hole in the exact position and the motion didn't change at all, the black hole's mass would have to be the same because the net force would not have changed. And that's lab. I think it was successful since I got the right answer. Thank you.